All right. So yeah, I'm going to be talking today about creating DSLs, specifically in the context of my fledgling DSL that I've been developing called spec-tacular. This is going to be a tale of spectacular success and of failure. So once upon a time, there was a company who had a problem. They knew that they were going to have a lot of financial data, a lot of critical financial data, and they needed a place that they could store it, manipulate it, that they could trust, and also that they could understand. So spoiler alert, they chose Clojure, right? And they also chose Datomic. Datomic has a lot of really, really good properties that they liked. It's data-driven. It's functional. It has a Clojure API. It has a free version, up to a point. You can audit the history of your database because nothing is overwritten, only added to. And it also has support. There's a Datomic community, and Cognitive itself provides Datomic support. So a lot of good features. The features that we cared the most about was that it was data-driven. Everything is data, right? So schemas. Your Datomic schemas are data. I do not mean prismatic schema. I really mean Datomic schema here. So if you're going to tell Datomic what kind of things are on your database, you're just using a vector of maps, of keywords, saying that I have a relation called a house color, and it has type string, just data. You install that on the database via data. You make a transaction, which is just data, onto your connection. You say you can add things just by using the db add keyword. You say, I have a house that is the color red. Or you can retract that fact about the house. My house is no longer red. Polls are also data. So if you have an entity on the database and you want to get the house color, then you can just say pull the house color with a vector of keywords, and you'll get back a house color that is the color red. Database queries, also just data, right? So this is finding a house in the database where the house has the color red. And you get back 1, 2, 3, 4, which is an entity ID, and then you can use Datomic entity in order to get that off the database and get back a Datomic entity thing. All right, so just to sync up really quick, just so that we're all on the same page, data is great because you have the power to create, inspect, destroy, rebuild, all with Clojure, already with functions that you understand. And as a bonus, it's all immutable. We like immutability, right? So I just told you a whole bunch of really great things about Datomic, and now I'm going to convince you that it's not enough, right? So spectacular exists for a reason, and I'm going to try to explain why. Right? So with spectacular, we wanted to still be able to use Datomic, but be cooler and safer when we do it. So our mission statement is to make the border between Clojure and Datomic a more convenient and safe place to live. And we do that with one really simple concept, that entities themselves should have types. Not just the attributes, not just the relations. Entities themselves should have types. And I'll explain what that means, right? So instead of schemas, we're going to talk about specs. So you can def spec a house. So now this is an entity type. I have a house type that has a color, which is a string. Almost exactly the same thing, except now you can talk about houses and not just about house color, right? So when you define your spec house, you get a map-based constructor. So you can create houses as if you were creating a map. You say, I'm making a house with the color red. And you also get a predicate to check whether a thing is a house, right? And then you can just use normal keyword access to get the color out of that house. And then when you actually need to interact with Datomic, Spectacular just gives you an easy way to make a schema out of these specs. You can say, just make a schema out of my house, and it handles all the boilerplate of making the spec for you. You can make a schema out of your single spec, lots of specs, or namespace, and then you can just use Spectacular to just take that schema and put it and create a database with it. And then if you want to add new things to the database, it's really succinct. All you do is you create a house and then just say, create that house on the database. Right? So you say, make a house that has the color blue, and then create it over there. And that's it. It does it. It returns it. It now has a dbref attribute, which is 1, 2, 3, 4, which is the entity ID over on the database. And you can still use keyword access. You can still say, just get me the color out of that house, and it'll say, well, that house is blue. And then you can use a soch bang, to then update the color attribute on the database to be the color white instead. And it'll give you back a new house. Well, actually, it's the same house, but a new object with the same DB ID, so it's still 1, 2, 3, 4, except now it is the color white. Right? So really succinct, create a SOC, just do the thing, very declarative. And spec-tacular also has a map-like query syntax. So for example, you can query for a house on the database where the house's color is red, and right here I'm using percent as in like Clojure's anonymous functions, the hash and then the percentage, so it's just talking about the first thing in the query. Or you can find a string where the string is the color of a house, or you can find both a house and a string that are related by color. So if you create specs, if you write down this spec in a file, spec-tacular will give you runtime verification of the entities that you're creating. If you try to make a house with the color 5, it'll say no, you can't do that, right? If you try to make a house with an attribute that it doesn't have, if you say the paint is red, it'll also stop you from doing that. But it also gives you static verification. So if you write a query, say you're looking for a house where the paint is the color red, it can tell you at compile time that that makes no sense. And if core typed is your thing, core typed Clojure is your thing, then you can say, well, I have a function called make white house, and it's going to return a house, and that house has the color 5. Static error. You can't type check that function. So there are a lot of other things about spec-tacular that I don't have time to talk about. There's also a DB cardinality many, which means you can have a bunch of different things in the same field. We support that. There's also a def union. It's a union type of specs. And then there's also generators. So core for Clojure test check generators, you just get them for free, and you can bombard your database with random stuff. We use that a lot. So thesis statement of spec-tacular, maps are cool. We really like maps, right? And when you write down your spec, it should be a lot easier to create, to update, and to query well-typed things on the database. Oh, and right, everything should be well-typed. So, does it live up to those grand expectations? The foreshadowing from the beginning of the talk suggests maybe no, right? So I'm going to go over a lot of properties that I think libraries, DSLs, APIs in general should have. And then I'm going to talk about, with very concrete examples, whether or not I think spec-tacular actually lives up to those good properties that I think everything should uphold. All right? So the first thing I'm going to talk about is types, right? That's what I keep hammering on. And I know we probably have a lot of mixed opinions about types in this crowd, so I want to put it really simply, right? Type system, if you are not with me, then you are my enemy, right? If you make me do things that I don't want to do and you don't give me anything for it, then why do you exist? So imagine you're Indiana Jones. You have been almost set on fire, put through a bunch of trials, almost run over with a tank. You get to the end, right? You think you're done, and this old guy comes up and tells you to fight him and select a type, a grail, before you can save the world and your dying father, right? I don't think this is going to be much of a stretch for some of the developers in the audience because you work really hard on your software. And I'm sure it could save the world if not for that pesky type system, right? But Clojure and Datomic are going to be really nice about it. They're going to keep you from taking the first of a number, because it's probably not what you want to do. But if you selected the wrong metaphorical grail, like maybe you took the first of a string, it'll try to do something with it, right? You get back a character. Maybe that's what you wanted. But spec-tacular is not going to let you do that. It's going to be a lot stricter about entities in specific to make sure that they have the right fields in them. So for example, if you have a spec that is a person, you can say people have hearts. And you say you have a spec that is a car, and cars can have paint, right? In Datomic, you would then get a schema with person/heart and car/paint. And if this was just Datomic, right, well, Datomic's not going to stop you from putting a heart on a car or putting paint on a person. That's just cool, because it doesn't have a notion of like a person entity, right? But spec-tacular is going to take a very firm anti-Herbie, anti-Blue Man Group stance here, right? Because you've said that cars can't have hearts. Cars only have paint. And you said people can't be painted, right? So it's going to do that for you. It's going to check to make sure that the Blue Man Group doesn't sneak in. So was that good design? Is it good to disallow things like this? Well, I think yes, definitely, because you wrote down a spec where they were separated, and they should remain separated. And it's an improvement over Datomic because Datomic only has a DB type ref, just like a pointer, right? And that's not what you wrote down. You didn't write down a pointer, you said people have hearts, which makes it a lot more predictable. When you get a person off the database, you know what you're getting. But unfortunately, it also entirely excludes DB type ref, right? So that means there isn't just like a generic pointer type. There's no any type in spec-tacular. And obviously, that's the thing that should exist. So we shouldn't have excluded that. Oops. So like I said earlier, you can also statically type these things. So if you wanted to statically type this function, find houses by color, that takes a color and a database and returns a seekable house, well, you can do that, right? Because this query here says, I'm going to give you back a sequence of houses, statically, which is quite nice. Is that good design? Static typing? Yeah, if that's your jam. It's totally opt-in. You can just totally ignore that type Clojure exists and not use this function. It's also a lot less work than trying to get the same result with Datomic, because you'd have to do the cast yourself. Okay, what if you have an entity type that absolutely needs to have a field? What if a man needs a name? Well, you can say that in spec-tacular. So you have a man that has a name field that is required. And if you try to make a nameless man, it will give you an error. And that's good design. You're completely unable to express this in Datomic. It's opt-in. You can just ignore the fact that required exists. It's simple. Required is required. And it's enforced everywhere. So runtime, if you try to make an error, if you try to make a nameless man, it's an error. And if a nameless man is sitting on your database, spec-tacular won't let you get it. Like, it just won't let a nameless man come into your domain, which is what you said. So to summarize, I think types should be an equivalent exchange. I'm making you write down a spec, and it should be worth your trouble. It should give you things back in return. And spec-tacular gives you a lot of things back in return. Verification, static, runtime verification, great. It's documentation. You can hand your spec file to someone, and they know exactly what's on your database. It's declarative. They can just look at it, read, now I know exactly what your entities are, which also makes it maintainable, right? And since you wrote down a spec, now I can make creation, update, and query very succinct. And it also gives you guarantees like required that are not enforced by the host. And finally, it makes refactoring really easy because you basically just change your schema and then just track down the places in the code where you need to make these changes, where it gives you static and runtime errors. But it also has some drawbacks, right? It takes space on the database. I mean, everything needs to keep track of what type it is. That's just a fact. But I think what's worse is that you actually lose control over the schema, right? Because now spec-tacular has control. It has, the from spec to database. It has control over your schema because it needs to be able to anticipate what's on your database, which means it needs to look like what it's expecting. And this is a problem. So say you have a spec called a large house and a spec called a small house that both have the same field. They're both a color, a house with a color. So in spec-tacular, when you make your schema, you get a large house color and a small house color, which is not what you would do if you were just using Datomic. You would use house color, right? That's a string. It's a string in both cases. House color makes sense. It's well typed. Spec-tacular totally excludes this right now. It disallows this idiomatic Datomic attribute, and it's not inherently unsafe. So that kind of control over the actual attribute name, some sort of polymorphism over house types, should have been available from day one, and it's not. So you have now lost control over your schema, and spec-tacular just kind of leaves you out in the dry, right? So on types, spec-tacular gets a B+. It excludes idiomatic Datomic, like I just said, but it also adds really new, interesting, useful ways to interact with entities, right? Okay. So, modularity. You do your thing, I'll do mine, we don't really have to talk about each other, right? So like Legos, right? They don't have to know about each other to exist and to be built up into new and exciting things. So I really want to talk about spec-tacular's ability for you to write modular programs and not about the actual modularity of spec-tacular itself. In Datomic, each database is pretty modular. It has its own schema, and you can talk about them separately. But in Clojure, you can split up information a lot of different ways, into different namespaces, into different functions, records, protocol types, all things like that. And spec-tacular does a pretty bad job unifying those things. Because, yeah, you can define specs in different namespaces, but it has absolutely no effect on the resulting schema. It's like, yeah, I see that you did that, but I don't really care. So it's impossible to isolate specs in Clojure that would not otherwise conflict in Datomic. And I'll explain that. But what it basically means is that the Legos are a lie. In spec-tacular, it is more like Highlander. Specs literally fight each other to be recognized. So if you have a namespace called people with weapons, and you define Highlander to have a sword, because that's what you care about, and you have another namespace with people with clothes that defines Highlander to have a kilt, you get the Datomic attributes Highlander sword and Highlander kilt, but spec-tacular knows about the two separate Highlanders. And this becomes a problem because spec-tacular kind of keeps them together, and you can make a schema with a Highlander with a kilt, and then you can send it over to Datomic, and Datomic can create Highlanders with kilts. But as soon as you try to query Datomic and just say, please give me a Highlander, you'll get something back that spec-tacular doesn't know how to deal with, because it actually doesn't know which one ended up winning. Which is a problem. Was this badly implemented? Yeah. Undocumented non-determinism is my favorite kind of non-determinism. Because half the time you'll get an error because it wasn't the spec it was expecting, and half the time it'll just let it happen, right? And then it's not good design either, right? Because these aren't incompatible abstractions, but they're being treated as incompatible by spec-tacular. And what's worse is that there's really quite a simple solution, right? You just need specs to provide modularity in Clojure, just define them in different namespaces or what have you, and then just use the database to provide modularity in Datomic. And the only time that you really care about the illogical schemas is when you have like an attribute Highlander age that is both a string and a number. That's a problem. That's what you really have to exclude. But Highlanders with swords and kilts, not really an issue. So spec-tacular gets a what is modularity? It's not even an F. Like, it didn't even try. It didn't even show up. So that's bad. Composability. Things fitting together, right? So it's the ability to have your Legos and then build an X-wing out of them. So spec-tacular does pretty well, having composable construct and update. So if you have creation or query, then you can directly pass those objects directly into a SOAP and just go. And that's good design, right? Because if you make a hash map, you can immediately associate. That's fine. That makes sense. That's Clojure. It's not really an improvement over Datomic, because Datomic gives you back an entity ID, which you can then transact onto. And what's worse is it's kind of an oversimplification, because it implies a lot more asynchronous safety than it really helps you with, right? Because if you create something, and then 20 minutes later you associate something onto it, what has happened in the meantime? It looks like it's the same object, but it's been sitting on a database, and maybe someone has come and just clobbered it, right? So even though in your code it looks like it composes really nicely, weird things could be happening. Right, and so spec and query, they're macros. They're big old macros, and syntax is not composable in the same way. So you can't compose queries. You can't just like say, I have one query, I have another query, make them the same query. You can't do that. And you also can't reuse parts of specs. So that's not good design. There should be a way to reuse these logical parts, even though they're macros. So spec-tacular is going to get about a C on composability. It's got some nice composability features, but it's not really trying that hard. Immutability. We love this, right? I'm preaching to the choir. And spec-tacular basically takes the if it's not broken, don't fix it attitude. Because Datomic databases are immutable, Datomic entities are immutable, Clojure maps are immutable, and spec-tacular just uses that and doesn't break it. So yeah, obviously that's good design. You guys all know that immutability is good design, right? So spec-tacular gets an easy A. Yay, it's like yoga class. I didn't even have to try. Right, but effects happen. Right, so does spec-tacular help you reason about these changes that really need to happen? Because we're talking about a database here, right? It changes over time. Side effects are real in Datomic. Transact does the side effect. It creates a new database. Something happens. And spec-tacular also has these create, assoc. These actually take real effects. So what spec-tacular does is it defines a lot of different update semantics that a SOAS can have, and I'll explain that. So the first thing that I want to talk about is by value. So if you just have this spec that is a house that has a roof, that you just say it's a roof, I don't care what you do with it, then you'll have by value semantics. So roofs can have shingles, which have types, which can be wood, metal, plastic. So we have roofs that are wood, metal, or plastic. And so if I have a blue house with a metal roof, and I want to add a new roof that is wood, what spec-tacular will do, it won't touch the metal roof, it'll just kind of leave it orphaned on the database, and it'll put that wood roof onto the blue house. That's by value. It won't try to mess with the metal roof, it won't mess with the wood roof, it definitely won't try to merge them. It'll just give you back a blue house with a wood roof and a metal roof, just kind of hanging out. Okay? That's often not what I want. Usually this is what I want, by reference updates. So if you instead put a link keyword on your field, I would have called it ref, but ref is a thing already. So it's called link. Link is by reference. Then what it'll do, so if you have a roof, a metal roof, and you change that to a wood roof on the database, right? So I SOAS a new shingle type onto my roof. You can see in Datomic that metal roof becomes a brown wood roof, right? But since these objects are immutable, back in Clojure land, if I try to get the shingle type of that metal roof, it's still metal, right? Okay, that's going to be metal forever, even if it's changed on the database. Now, what if I continue and put that metal roof into a house? What color is the roof of the house? Well, spoiler alert, it's brown. There's a picture right there, it's brown. And that's because you've told it to do it by reference. Like, don't look at what's inside this object, just take the DB identity and put it at the place, right? And so on the database, that was already a brown roof, so you get a house with a brown roof. Okay? That's what I want like 99% of the time, which is why this exists. And the last thing is component. It's almost like Datomic component, so you just add the component keyword to it. And what it's saying is that this roof is kind of a component of this house. It doesn't make sense outside of this house. And so when you have a blue house with a metal roof, and you put on your wood roof, it deletes the metal roof. It doesn't leave it stranded on the database. And then it gives you back the blue house with a wood roof. So that's component. So 3 different flavors of almost the same kind of thing. Is this good design? Yeah, I like it a lot because it's really easy to reason about the asynchronous changes because you've been very explicit about what it should do in the face of weird things happening. And it's really easy to specify. You just add a keyword and the semantics change. But component in Datomic is slightly different. For those of you that know Datomic, it won't actually retract the metal roof. That'll still be there. But I named it the same thing, right? So that's not helpful for Datomic programmers coming over here because you're going to wonder why your metal roofs keep getting deleted. And what I've said explicitly is that these don't try to do merges, right? Well, what if you actually need to do a tree update, right? Those are things that we do. Spec-tacular is going to make your life hell. It's not going to help you at all. You basically have to go down in the tree and set that 5 to a 6 that you want it to do. Because if you try to do it with just spec-tacular, it'll probably end up trying to recreate your entire tree, which is not what you want. And so even though I've said, maps are really cool, I didn't give you a SOAS in. I didn't give you update in. And that's not helpful. So spec-tacular gets a B, and then it really does keep scary things from happening in general. You don't really have to think too hard to keep scary things from happening, but it also doesn't help you with the scary things, right? Sometimes scary things need to happen. You need to do these weird asynchronous merges, and it doesn't help you with them. So next, extensibility. Leaving room to grow in your framework. So spec-tacular doesn't give you 5 specs and make you use just those 5 specs, right? So you can extend the specs that your database has, obviously, so good. What about the base type environment, right? So Datomic base types are not extensible, and that's totally reasonable, right? You can't just say, I have this new type, now please Datomic work with this type on your database. You can't do that, fine. But in spec-tacular, the base types are also not extensible. So if you want, it's actually not exactly the same base type, We have more interesting types like, for example, calendar day. As a financial company, we really just care about banking days. We don't care about like instance with time. So I created a calendar day, implemented as Datomic's inst on the database, but when it comes on and off, it's basically coerced into a date time with only the year, month, and day fields, right? But I had to write that into spec-tacular. I couldn't just define that in my engine and like not have spec-tacular know about that, because spec-tacular's base type environment is not extensible. And that's not good design, but it's also not bad design. It just hasn't gotten done yet. Like, it's there, it's just not done because finite hours in the day. Okay, but spec-tacular is actually quite extensible with respect to databases themselves, because the coercion of entities is left open. So it's database agnostic. So if you wanted to come in and give an API for data scripts, you could totally do that if you wanted to, which is, of course, good design. All you'd have to do is basically write the coercion from whatever entity type you have in data script into spec-tacular. And you'd be able to use all the nice spec-tacular things with that. So that's good, yeah. Specs themselves are just data. So if you don't like my Datomic API, you can write your own. All you need is the spec, which is data. It's a record of fields with types, right? And you can just write your own assoc, write your own create. I'm not going to stop you. So yeah, good. Unfortunately, though, the macro syntax is not extensible. You can't, for example, define your own query types, right? You can't add new kinds of updates into existing functions. And it's not bad design. It's also not good design. I just don't really know why you would want to do that. So if you can come up with a reason why you want to do that, then I might make this extensible. So it's just not there. So spec-tacular gets a C+ on this, because although the opportunities are there, I basically just told you, go do it yourself. I'm not going to help you make a data script API. You have to basically crawl through the code and do it yourself. Fine. And some extensions, like the base type environment, are disallowed for no particular reason. The last thing I want to talk about is incremental abstraction, because I'm basically sitting between Clojure and Datomic, which means I'm building on the shoulders of giants. And I shouldn't forget that. Right? So I'm going to explain this with this really beautiful picture of Multnomah Falls. And I'll explain how. So let's talk about query, for example. Datomic query, as I said before, is just data. Spec-tacular query is a giant macro that expands to a Datomic query, which doesn't give you any control. It doesn't let you inspect the query that it generated. It doesn't let you tweak it, and it doesn't let you change anything about it before you actually end up querying the database, right? Datomic pull, also just data. You might have even forgotten about pull since I haven't mentioned it. Well, because spec-tacular pull doesn't even exist. I didn't implement spec-tacular pull. So if you want to do pull, you have to do it with raw Datomic. But now you've lost control over the schema, which means now you have to know what schema spec-tacular generated, which means now you have to work in terms of large houses and small houses instead of the house color that you wanted, for example, right? So that's not good. Datomic transact, just data. But spec-tacular just tries to hide the transaction data, right? When you do create or assoc, it doesn't tell you what it did, it just gives you back the object. What if you wanted to change that before actually creating those? What if you just wanted to see what spec-tacular wanted to do and then maybe do some tweaks and then send it off to your database? Nope. No, you can't do that. So spec-tacular is just way up at the top there with its fancy queue and create and assoc, and Datomic is way down there at the bottom with its query and transact and its pull. And you might be thinking, I was promised a bridge. I was promised this 5-minute hike to this bridge where I could look up at the pretty waterfall, and I could look down at the pretty pool, and exist in both worlds simultaneously. Be able to look at spec-tacular, look at what spec-tacular's doing, and look at what Datomic's doing. Just kind of live in between, right? And spec-tacular does you one worse. You cross the bridge, and then it burns it behind you, right? So that's not good. So yeah, it's bad design. But it's also not horrible, right? It's really easy for beginners. If they wanted to just sit up at the top of the waterfall and be like, ooh, pretty waterfall, like, that's perfect, right? Like, really easy for them to get started, really easy to create, query. They don't have to think about it too hard. It also gives you static typing. These are giant macros because it has to exist at compile time in order to give you static types about the things that are expanding. But I told you it was opt-in, right? I told you, like, you don't have to care about types, but now you're losing something because I want to give you types. So it's bad. It's bad because you have no control. If you're using query, like spec-tacular's query, you have no control about what comes out. You have no control about the transaction data. You have no information about the transaction data, right? So even though you took the time to write down these specs, it ends up hurting the person who actually knows Datomic. So a lot of times I know Datomic, and I find myself writing Datomic instead of writing spec-tacular in our engine. So spec-tacular gets a D on this, because it is really friendly for beginners. But as soon as you have something complicated that doesn't just quite fit in my query syntax, it's like, well, too bad. Fall down the mountain, use Datomic. I don't like falling down mountains. So where do we go, right? Spec-tacular is not going away. Spoiler alert. It actually works really well. Spec-tacular works in production, as long as you're willing to make the compromises that I talked about. And the reason that we make these compromises is because we have a guarantee that illogical data doesn't reach the database. It doesn't go on, it doesn't come off, and even if someone tricks the database into having illogical data, you can't get it back off. And that's a huge guarantee, which is why we use it. So there's a lot of things that spec-tacular could improve on. Just as a reminder, this is version 0.6.0. It's existed for a couple of years and hasn't gotten a lot of love, so there's a lot of places that it could go. It could provide tree updates. It could provide namespace isolation. It could give you schema control. It could give you schema migration, which I didn't even talk about. Pull would be a nice thing. And maybe it could support data script, Clojure script. Those are all good things that it should have, right? And I just want to remind you of the general properties that I talked about. So if you are about to think about picking up a new library, API, DSL, or if you're thinking about implementing a library, API, or DSL, think about these things if they make sense in your context. Just think about them, please. So thank you. Thank you to the organizers who are putting on this wonderful conference. Thank you for giving me the third talk slot so I can enjoy the rest of the conference. Thank you to all of you for listening, and thank you to all of the people who have either contributed to spec-tacular or been a soundboard for me bouncing design ideas off of. Gonna wait 1 second on questions. Make sure you have a mic before you start talking.
Hi. Do you have ideas about how you might be able to use, say, something like a module, attribute set, or some sort of modular description of a set of attributes which you might want to be able to move around and use in different types? Is that something you think might be possible?
Yeah, absolutely. It would be really nice to package things up and just say, this one gets a package, this one gets a package, this one gets a package. Yeah, absolutely. I'm not sure exactly how that would look, but that is definitely something I'm thinking about.
Cool. So first of all, just meta, really impressive presentation. I find it really impressive that you kind of have ownership of the library and you gave very objective grading based on software engineering pillars. That was really, really impressive. Great presentation, great style, great slides and all that. I wanted to ask about namespacing. That seems like something that you can just concatenate the namespace on the thing.
I know, right?
How difficult... How difficult is it really? When should we look forward to that?
So, yeah, I know, right? So it's really easy to do that with like the spec name itself. Like, oh yeah, just put the namespace on it. But what would the attributes look like in that case? Because I do exactly make the namespace of the attribute be the namespace of the thing you define. So you'd still kind of get your Highlander that has the two different things, and I'm not sure exactly how to reconcile that right now. Maybe that's totally fine to have, right? Maybe it's not. So that's like, yes, that seems like an obvious solution, and yes, that is definitely the way that I'm looking towards right now, but I'm not sure what the consequences will be of that.
Thank you. Can you elaborate a little more on how hard it will be to implement support for DataScript? I think it's kind of a very strong use case for newcomers to Clojure community, and especially in Clojure script.
Yeah, I would love to do that. I don't know much, if at all, about Clojure script or about DataScript, but in general, I can speak that basically all you need to do in order to hook into spec-tacular is define one def method that takes whatever kind of entity you have in DataScript and tells spec-tacular basically how to translate that type into a spec-tacular spec. So that's really all spec-tacular Datomic does, is define that def method.
Another question. If you are going back and editing types that you've defined, and then rerunning, like, does it manage sanely the migration of one set of schema to the next? Or like, is there any life cycle around that?
Yeah, so I can't really speak about schema migration itself because we actually don't have a persistent service at SparkFund for reasons. So I'm not exactly sure what schema migration would look like in this case, but it does give you the new schema. It can do a diff for you, and basically it'll tell you all the places in your code that need to change via verification that you've written in. I think I saw a question. Yeah.
So as a library maintainer, how are you weighing these competing drives to maintain backward compatibility, which I'm sure is a priority, and adding from this feature set you're looking at?
Yeah, that's a good question. I'd say you basically just have to weigh the amount of code that will need to change in order to support this and the benefits that you'll get from it, right? So every time I make something, I'm like, well, this will probably take me or the average person like a day to update all their code, or basically something like that. And then, but, you know, how much is this going to do for me down the line? Like the next time that I write a query, because I write, you know, a query a day kind of thing, how much quicker is that going to be for me? And then, so I basically let it build up to a breaking point where I'm like, I can just keep doing this, I can just keep doing this, I can just keep writing these awful queries, and then I'm just like, no, I can't do it anymore. And then I fix it in spec-tacular, and then I go on with my day.
I was just wondering if you're thinking maybe down the road, it seems like right now it's really good at guaranteeing that your writes don't corrupt the database, but that the reads become problematic because you can't do like projection or read into a different schema. If that's something you're thinking of, like having a read schema where you can do more like ad hoc, like read parts of this and parts of that into this new entity.
Yeah, you know, I hadn't thought about that, but I would really love to talk to you offline about what that would look like.
Hi, so I really liked the grading criteria that you gave for yourself. I'm curious whether you apply that when you're to other people's libraries when you're considering using them.
Not that explicitly, but those are certainly things that I look for. It's kind of hard to give those grades until you've like tried to use this library every day. You know, like I wouldn't expect someone else to be able to just look at spec-tacular and be like, oh yeah, it does types well, but it doesn't. Yeah, I don't know. I look at all those things, but I don't give grades, yeah.
It would be really cool if that was, like, if you could see that when you were deciding whether to use the library
that
or not.
Would be nice,
like,
wouldn't it?
So, like, someone should do that. And then,
how are we doing on time? Probably wrap up? Okay. All right. Thank you.